to us. Well, Captain Schrader, you're back. Thank you very much. But there's Dale Chihuly. I just wanted to get right into him. He's even playing a role in this.
He is. You know, this is about awareness. And so we started wondering, you know, what would get people down to the beach looking to see what was there. A lot of, I mean, you know, there are people who do that regularly, but there are millions who have never gone. And Dale Chihuly's name is known worldwide, internationally famous glass artist. And our association with Dale, he volunteered to blow some glass floats. People love finding Japanese glass floats that have been out there for, you know, 10, 20, 100 years. They float up on the beach. So Dale volunteered to blow some of these floats. They'd end up perhaps a few of them on the beach. We'd ask people to go find them and look to see what else is out there and give us a report on that. And that, you know, it's about awareness. You have to be aware of a problem before you can start educating about what's going on and what the problems really are.
Perfect segue. Let's talk about one of the missions, education. Teachers are actually going to be able to interact with what you're doing.
Teachers are coming aboard for different segments of the trip. The first teacher onboard educator, we're calling them, comes aboard in Barrow. We're sailors. The core group here are sailors, and we're adding a teacher and a scientist. And part of that is so that the teacher can help us with the right words, help us talk about what it is we're seeing. And on the website, as you mentioned before, there's a wonderful curriculum, K-8 curriculum, that will be free to teachers, anybody who has access to the web in Spanish and English. The teacher is helping us define what it is we're seeing, talk about it in the right language, and make it an educational experience and relate it to the classroom.
One of the things that you're going to do is you talk about on the website is building a sea perch. What is that?
A sea perch is a little ROV that can go in the water, and it's a little submersible. It can have a camera attached. It can sample some. It can do a number of things, and it's an exercise that anybody who's ever had a remote control robot or anything like that is going to love. We should have a look.
The neat thing is these cost about $150. They're designed so that even fifth graders can build them with a little bit of guidance, and it serves a dual purpose for both science and education. You can mount sensors on here to look at different aspects of water quality, like salinity, temperature, pressure. And the neat thing about building these is it took me about 3 days to build 2 of these. You learn about ocean engineering. And this is all sponsored by MIT Sea Grant College Program, which is funded in part by the Office of Naval Research for this, to get students interested in science, technology, engineering, and mathematics.
And all of this is available. You can learn more about it by going on the website aroundtheamericas.org. Let's talk about your science mission too. You got some very cool science stuff, including something that's some kind of rotor or robot, or what is this that's going to be on? We're going to be showing it on the screen.
It's a sea buoy that is helping with weather and ocean temperature models and measurements. We'll deploy it someplace in the Barrow Strait, and it's those buoys. When people listen to weather forecasts and listen to weather predictions, sometimes we wonder, you know, how does anybody make those? Well, it comes from a sampling of what's actually historically happened. There are buoys floating around in the Arctic and in other oceans now, sending data back so we know what the sea temperature is, we know all kinds of things. We're helping with those measurements. We're seen as a platform of opportunity because Ocean Watch is going places where normally scientific ships and expeditions don't go.
There's an aspect of cloud watching, cloud measuring. How is that going to be any different there than the clouds we see up here?
Well, it actually is correlating with what the satellites are seeing. It's registering the satellite data to make sure that it's reporting correctly. And again, we're going in places where normally there aren't observers. So on a regular basis, we're making an observation, cloud cover, what it is, how that relates to what's in the water, and how much you can see below the surface of the water. At the same time, we're measuring temperature and salinity. There are computers going on down below now that are actually testing this water and registering data that will go back to any number of outlets. And our scientists on board are making sure that that equipment is working properly. It's pretty exciting stuff. again, it's real science and real education on board. We'll have a scientist on board for each leg of the trip.
And one of the things also you're going to be doing is a jellyfish survey. Why is that important as opposed to any other fish?
What's really fun for me is that I'm learning about this as others are learning about it, and this is one of the most fascinating. Jellyfish, it turns out, are really the canary in the mine shaft. You know, when the canary dies, you better get out because the gas levels are bad. When jellyfish blooms happen in great numbers and take over a harbor, and that's happening in East Sound, out here in the San Juan Islands, it's happening in West Africa, sorry, it's happening in some places in Asia. Jellyfish, when they get to a point they're just covering the surface, they're doing a number of things. They're telling us that the ecosystem has been disturbed. The fish are going to go away, and when those jellyfish die and decompose on the bottom, they're using up all the oxygen that's there in that decomposition process. So it's a dead zone. Not many people are studying jellyfish, but there's a very high correlation between a lot of jellyfish and bad things happening in the ocean. So we're sampling jellyfish along the way. We're actually going to scoop some up, take a little sample, put it in a jar, and send it to the jellyfish experts all along the route.
Wow. I wish we had about 2 hours to go over the science and the education part, but we don't. I got to talk about the crew. You've got David Logan as your first mate. Tell us about David.
David and I have sailed all over the world together. He's been my ground support for my first Cape Horn and Around the World Alone expedition. He met me in several ports to make sure the boat was in good shape. When I started thinking about this project 2 years ago, I was smart and said, look, I can't go any further with this unless David agrees that he'll be part of it. He's the reason that Ocean Watch will be ready on departure day and in each one of the ports ready to go on the next leg. He's just the best there is.
David Thorson was one of your watch captains, and another watch captain is Herb McCormick.
David Thorson's qualification is that I'm from Nebraska, he's from Iowa, so I thought, you know what, there better be two of us. David Thorson has great ocean experience. He's an adventurer, he's a traveler, but he's been through the Northwest Passage. 2 years ago he came through. He's local knowledge up there, if you will, an excellent videographer and still photographer, and again, that's part of the education and awareness. Herb McCormick, best sailing writer I know, we've worked together on other expeditions around the world and other adventures and races. I've sailed with Herb a lot, great on board, but he can make almost anything into a wonderful story, easy to read and educational. Herb was, when he heard about this project, was there immediately.
You've got a tremendous planning committee. Of course, you're heading it up as the captain and the project director. The Pacific Science Center's role, I just love the Science Center, and we're here in part because of them.
You know, that really made this, the Science Center coming on as a partner really made this into what it is right now. They have such a huge reach and such a great reputation for science, and translating the science that's happening, you know, in the laboratories and the, you know, at the universities, translating it so that mere mortals out here can understand what's going on. And one of the first things they did, they hired just a top-notch oceanographer, Dr. Chris Ludwig, to be the project manager for our expedition. And she brought to us the professional curriculum and the scientists that are on board and put that all together. Terrific partner.
So you've got NASA, UW, Swedish Hospital, so many others involved. How is this funded?
Well, it's funded, you know, we started thinking about this and talking about it 3 years ago when the financial world was a little different than it is today, you know, and so there are stresses and strains there. And looking at this project over really not just the 1 year of the voyage, but the 5, 6, or 7 years for the carry-on, for the documentary and for the book and for traveling exhibits, became a pretty big project, $7 or $8 million budget over that period of time, about $1 million a year. When the collapse of the financial institutions happened, we knew that we had to sort of reset this and look at it in stages. The voyage itself is a $2 to $2.5 million 18-month, if you count before and after. So we knew we needed to go not to the big institutions that were having big problems, but to the smaller foundations who are dedicated to science and education, and to individuals out there who think that marine science should be taught in more schools and who think that access to marine education should be free. not just in North America, but also in South America and in Canada.
So Captain Schrader, what it is that even individuals can be involved in this project through helping to fund it. Just go on the website, aroundtheamericas.